Alright, in this video we're going to talk about Unit 6, Objective 4, Mean Value Theorem. So AP is going to ask you to show that one of two things are going to exist on a certain interval. They might ask you to show that a certain y value exists or that a certain derivative exists on a given interval. Now we saw previously that intermediate value theorem is going to help us find y, or help us show that the y values exist. If they ask for a certain derivative, what we're going to have to use is the mean value theorem. So what the mean value theorem says is if f is continuous on the closed interval a to b and differentiable on the open interval a to b, then there's going to be a number c on the open interval a to b such that f prime of c, so the derivative at that point, is equal to f of b minus f of a over b minus a. So that should look familiar. That's just the slope formula from your Algebra 1 class, your average rate of change. So essentially all this is saying is that somewhere on the interval, the derivative of your function is going to be the same as the average rate of change between your endpoints. So that's what the mean value theorem states. Now, what this would look like if we saw a graph, so say we have just some random function from a to b, and let's just say it looks like this. If we were to find the average rate of change between a and b, somewhere on this interval, the derivative of the function, so the slope of the function, is going to be the same thing. So in this case, it's going to be somewhere up there, right? The slope of the tangent line is going to be the same as the slope connecting those 2 points. Every so often, AP will ask you about Rolle's theorem. Most of the time, they don't call it by the name Rolle's theorem, but sometimes they do. All Rolle's theorem is a very special case of the mean value theorem, where f of a equals f of b. So if that's the case, we have to kind of think, well, what does that mean about f prime? What f prime is guaranteed? Well, if we look at a picture, if this is a and this is b, and we're saying f of a, so the y value at a, has to equal the y value at b, and let's just connect it with a function that looks like that. We're saying that the average rate of change between them, again, that doesn't change, has to be the same somewhere on the function. So if we look at f of a and f of b are the same thing, then we know that somewhere f prime of x has to equal 0, right? So we can see it graphically here. If we think about it up here, if f of b and f of a are the same thing, we subtract them, we're going to get a 0 in our numerator, so our derivative is 0. So Rolle's theorem is a very special case of mean value theorem, and that's just going to help us find, or prove rather, that f prime of x has to equal 0 somewhere on our interval. Now, just like IVT, the mean value theorem is not going to tell you where these things happen. It doesn't tell us where the derivative is 0. It doesn't tell us where that derivative happens. It just tells us that it does. Now, our AP justification is similar to IVT, except we need to cover our bases a little bit more. So we need to say, since f of x is continuous and differentiable, so continuous on the closed a to b, differentiable on the open a to b, and then we're going to show the average rate of change between a and b equals some value k, then the mean value theorem guarantees, and this is where we're just going to copy the rest of the question, guarantees a value c on the interval a to b such that f prime of c equals k. So we have to show them, just like with IVT we stated what the endpoints are. In this case, we're going to state what the average rate of change between the endpoints is. So let's look at a couple of examples here. The first one, this is a multiple choice question. It might pop up like this, although MVT doesn't show up too frequently as a multiple choice question. But it says if f of x equals cosine of x, the mean value theorem guarantees somewhere on the interval 0 to pi over 3 that f prime of x equals something. So they're telling us MVT works here, so we don't have to think about it. But it's not a bad idea to say, all right, is cosine continuous on that interval? Yes. Is cosine differentiable on that interval? Yes. So we're going to be okay to use MVT. But all we need to show here is if we're trying to find which of these things is guaranteed, we just need to find the average rate of change between these things. So we can say cosine of pi over 3 minus cosine of 0 over pi over 3 minus 0, somewhere on our interval, f prime of x has to equal that value. So working this out, cosine of pi over 3 is 1/2, cosine of 0 is 1 over pi over 3. So we're looking at negative 1/2 divided by pi over 3. So if we multiply by our reciprocal, we're getting negative 3 over 2 pi. So our answer here would be A. So you're more than likely going to see MVT on a free response question. So here's one way that it could show up. So the functions f and g are differentiable for all real numbers and g is strictly increasing. The table above gives values of the functions and their first derivatives at selected values of x. The function h is given by h of x is f of g of x minus 6. So it says, explain why there must be a value c for the interval 1 to 3 such that h prime of c equals negative 5. So when we see this, there must be a value of the derivative. That tells us right away MVT. If this was just h of c, we would be thinking IVT, but MVT is what we want to think about because we see prime. Now up here they say f and g are differentiable. They don't say that they are continuous, but don't forget that differentiability implies continuity. So when they say differentiable here, they're also telling us that it's continuous. So explain why there must be a value c on 1 to 3 such that this happens. So what we need to say is, since h of x is continuous on the open interval, closed interval, 1 to 3, and differentiable on the open interval 1 to 3. And so we laid the groundwork here. The two conditions are met. We're continuous, we're differentiable. Now we need to show the average rate of change. So we're going to say that h of 3 minus h of 1 over 3 minus 1 is equal to, so h of 3 is f of g of 3. So g of 3 is 4, f of 4 is negative 1, minus 6 is negative 7, minus h of 1 would be f of g of 1 minus 6, so g of 1 is 2, f of 2 is 9, 9 minus 6 is 3, over 3 minus 1, so that's going to give us negative 10 over 2 equals negative 5. These numbers here should match, right? Because that's the only thing MVT can guarantee is the average rate of change. So we're getting negative 5 here, so that's good. So since we're continuous on the closed interval, differentiable on the open interval, and our average rate of change is negative 5, MVT guarantees. And then we're just going to copy the rest of the question. A value C for 1 is less than C is less than 3, such that h prime of C equals negative 5. So very similar to IVT, except we're finding average rate of change instead of endpoints. So one more real quick example, and then we'll call it quits on this video. So let g be a continuous function with g of 2 equals 5. The graph of the piecewise linear function g prime, the derivative of g, is shown above for negative 3 to 7. So find the average rate of change of g prime of x on the interval negative 3 to 7. So let's start there. So the average rate of change of g prime. So we're trying to find the average rate of change of these things from negative 3 to negative 7. So we're going from here, to positive 7 to here. So we're going to say g prime of negative 3, we can do it this way, divided by, or minus g prime of 7 over negative 3 minus 7. So g prime of negative 3 is negative 4, minus g prime of 7 is 1, over 3 minus, or sorry, negative 3 minus 7, so we're going to get negative 5 over negative 10, which is negative 1/2. So we found G prime, or I'm sorry, the average rate of change of G prime on this interval. Does the mean value theorem applied on that same interval guarantee a value of C for negative 3 to 7 such that G double prime is equal to this average rate of change? Why or why not? So they're basically saying, does the mean value theorem work? It's really looking at it a step farther, though, because most of the time we're looking at F and we're trying to prove something about F prime. This time we're looking at G prime and we're trying to say something about G double prime. But if we think about our justification, before it said F is continuous and differentiable. So in this case it's going to say G prime is continuous and differentiable. So if we start here and we go here, is this continuous? Can I draw this entire graph of G prime all the way to 7 and not pick up my pencil? So that works. It's continuous. The next part is differentiable. Is this function G prime differentiable all the way from negative 3 to 7? And the answer there is no, because if we look, we have here, here, and here, we have corners, or we could call them cusps and still be all right. We have corners or cusps, which means we're not differentiable. So the two conditions for the mean value theorem to work are not met. So this is not going to be guaranteed. So we can just say MVT does not guarantee that G double prime of C equals negative 1/2 because G prime of X is not differentiable on the interval. So since we're not differentiable from negative 3 to 7, we can't use MVT to guarantee anything about G double prime. So that's going to do it for this video. We will see you in the next one.